Okay, so in this video we're going to take an introductory look at pointers in C++. Alright, so what exactly is a pointer? Pointer is just simply a data type that points to another value stored in memory. So let's look at a logical representation of memory here in which we have some addresses, we have some values associated with particular address locations, and we also have some variable names here. So we have this variable name P associated with this particular value. We have the the variable name X, which is associated with the value of 25 here. And we're going to assume that X here is an int variable, and we'll assume that P is a pointer variable. More specifically, we could say that P is an integer pointer, meaning it's capable of holding addresses or memory locations associated with integer values. So we can see here that the address associated with X here is the address 0003, and that in fact is the value that's being stored here at this particular memory location associated with P, our integer pointer P. So P here is able to reference this particular memory location, and if we're able to get to that particular memory location, we can also get to the value that's stored at that particular memory location. And right now this may seem like a very convoluted way of getting to the value of X, since we simply have X over here. Why not use it? And in this particular case we could and we should use X. We shouldn't be introducing a pointer unnecessarily. But later on we're going to see examples where we're going to need pointers. There's no way for us to get around not using pointers in many situations in C++ programming. So the big idea here is just to know that pointers are a data type and they hold addresses of other values in memory. Alright, so now let's look at the syntax for declaring a pointer in C++. So just like you declare any other type of variable in C++, you have to specify both a type and a name. Except now, whenever you specify the type, you also include this asterisk here. So if you were wanting to declare an int pointer, you would specify the type int, then this asterisk here, which we would read as pointer, and then whatever the name should be. So once again, we're just specifying both the type and also the name here. And depending on what book you read, or if you look at code online, you may see this asterisk here sitting either next to the type or immediately to the right of the type, or it could be immediately to the left of the name. And either version of this is fine, so the C++ compiler has no problem examining this and being able to decipher exactly what's going on, that you are in fact declaring an integer pointer. This is my preference though, because I like to be able to read this as int pointer, and this just simply being the name of the pointer, because anytime that we're going to be making use of this pointer P, we'll be using it via its name. And if you want to declare other variables or other pointer variables of other types, you would just specify their type in the asterisk. So if you wanted to be able to reference a particular string address, then you would say string asterisk space and then whatever the pointer name. In this case we have Q. That's pretty much it. Declaring a pointer, specify the type, asterisk, space, and the pointer name, unless you want to go with this convention, which is also very popular. Okay, so now that we know how to declare pointers, let's take a look at some of the common pointer operations. The first one we'll look at is the address of operator, and then we'll take a look at the contents of operator, which is also known as the dereferencing operator, and see how those work. Alright, so let's take a look at an example using the address of operator. And we're going to go back to the original example that we started with when we first started talking about pointers. So in this example here, we have this integer variable X, and we have the value of 25 assigned to X. So we can imagine here in memory that at some particular location, we're saying at address location 3, that we have this value of 25, and we have the variable X associated with it. Now what we can do is get this address here by simply using the ampersand, the address of operator, and prefixing it before the variable that we want to get the address of. So we're saying that we want to get the address of X here. So once we have done that, we can assign that particular address to an integer pointer. In this case, we're declaring an integer pointer P, and we're assigning the address associated with X. So once we finish this particular line of code here, we would have this logical representation here in our memory. So we have this particular value of 3 for the address. It's associated with this, so we're indirectly able to get to this particular value. Now, if we were to go in and do a cout operation, so if we wanted to print out the value of P to the console, remember that P actually holds an address. So what you would see is this value 0003 being outputted to the console. And that's pretty much what's going on with the address of operator. It's just retrieving the address of some particular variable. Okay, so now that we know about the address of operator, let's take a look at the contents of, or the dereference operator. And this particular operator is going to allow us to get values stored at an address held by a pointer. So what does that mean? So we have this pointer P, and it holds this address value of 3. And if we're interested in actually getting to this value 25 that's stored at this location, what we have to do is dereference this pointer P by using the little asterisk symbol. So here, if we did cout and dereference this pointer P, what we'll do is instead of getting the address here, it actually gets the value that's associated with that address. So it's getting this value of 25. So we get the value of 25 being outputted. And this may seem like a very convoluted way of getting to this value of 25 since we have this variable x. But later on we'll see examples in which the only mechanism we have to get to something is through a pointer, because it will be an unnamed memory location. We will not have a variable associated with it or a variable name. We'll only have a pointer that's associated with it. And we'll look at that later on. All right, I want to talk about how we can dereference this pointer P and it be the same thing or just an alias for x. So however you think about x being in a particular expression, you could think about dereferencing this pointer P meaning the same thing. So in this very first expression here, we see that x occurs both on the left-hand side of the assignment statement and also on the right-hand side of the assignment statement. And they have two different meanings. So on the right-hand side of the assignment statement, we're saying to get the value that's stored at this particular memory location associated with x. So we're just simply getting this value of 25. So we'd say 25 plus 5, and then on the right-hand side, or excuse me, on the left-hand side of the assignment statement, this x here is saying that we want to store this result here at the memory location specified by x. So we'd have the value of 30 being stored at that particular memory location designated by x. So in this very next example here, this is not too much of a leap from what we did before. We're still dereferencing this pointer P. So instead of getting the address, which is what's actually stored in P, what we want to do is get the contents located at that particular address. So we're getting the value of 30, adding it to 5, and then storing it back into the variable location specified by x. So here we would update that and now have the value of 35 stored at that location. In the very last expression that I have here, I have the dereferencing of the pointer P on both the left-hand side and the right-hand side of the assignment statement. Once again, dereferencing this pointer P would just get this value of 35, but now when we dereference this pointer P on the left-hand side of the assignment statement, it allows us to store a value at that designated location here. So we're designating this particular location here where we want to store a particular value, just like what we had with x. So we would have 35 plus 5, which would be 40, and store it at that particular memory location. So you can see that this dereferencing of this pointer P is serving the exact same purpose as this variable x. They have the same meaning. One last example that I wanted to look at is if we made use of the ampersand operator and then did a dereferencing on P. So using what we just discussed, we could say that this dereferencing of P here would just be the same thing as saying x, and if we were to get the address of x, that would just simply be this value of 3. But we can also think of this ampersand operator, or excuse me, the address of operator, canceling out the dereferencing operator. So anytime we see these in pairs, we can think of them canceling each other out. So fundamentally, this is just saying cout the address stored there at P, since P is a pointer, which would be 3. Alright, so in this video so far we've looked at the concept of a pointer, and we said that a pointer was just simply a data type that points to or references another value in memory via that value's address. So a pointer actually holds an address. And we also looked at the address of operator, and the contents of are also known as the dereference operator, and how those related to pointers. But all the examples we saw were rather contrived and aren't really the way that pointers are actually used. So how are pointers really used in programs? Well, one way is to refer to new memory reserved during program execution. And we'll look at this concept more closely in upcoming videos, because it turns out that anytime that we allocate new memory during program execution, then what was being returned is an actual pointer or an address to that particular memory location. So we need to have pointers that hold the address of where that new thing is being allocated in memory. We can also use pointers to refer and share large data structures without making copies of these structures. So this is often a good thing. So you can imagine a pointer may be referencing some particular file that you may be reading, and you may not want to make copies of that file, that large data structure, but you can just use a pointer to address, to reference that particular thing in memory. And then finally, we can use pointers to specify relationships among data. So later on, we'll be looking at these data structures called linked lists and trees and graphs, and we can use these pointers to show relationships between these various data items in these structures. So that's pretty much it, introduction to pointers, and we'll have lots more videos where we'll be making use of pointers in the real sense and not just simply having contrived examples.